Hello bachcho, let's read the question. So the question says, a thin wire of length L is carrying a constant current. The wire is bent to form a circular coil. If the radius of the coil thus formed is equal to R and the number of turns in it is equal to N, then which of the following graphs from the below figure represent variation of magnetic field induction B at the center of coil? So let us first revise the key concepts behind this question. So the first key concept behind this question is magnetic field induction which is denoted by B is given by the formula mu naught upon 4 pi into 2 pi Ni over R. Here N is the number of turns, I is the current in the circuit, R is the radius of the coils, and mu naught upon 4 pi is constant. So it can be further solved to mu naught upon 2 into Ni over R. Now let us proceed to our question, what is given to us for solution part. So in the solution part we have a thin wire of length L, let's suppose this is a wire and its length is given to us as L, is converted into a coil of radius R and number of turns is N. So its radius is capital R and number of turns is N. So 2 pi R will be the circumference of one turn and number of turns is N. So 2 pi Rn must be equal to L because it is the length of same wire. Hence from here we get N is equal to L upon 2 pi R. Now putting this value of N into the formula of magnetic field induction, we have B is equal to mu naught upon 2 into Ni over R. It will be equal to, putting value of N, we have mu naught upon 2 into L upon 2 pi R into I over R. Hence it becomes mu naught upon 4 pi into Li over R square. Hence here L is constant, I is constant and whole of this thing is constant. Hence we can say that B is inversely proportional to R square. So this is the relation of B with R. Let's highlight it here. And now let's check the graphs which gives us the correct relation between B and R. So graph 1 shows B with N. Graph 2 shows B with R. So from here graph 2 is correct because it shows the relation B is inversely proportional to R. Now we have to check the relation of B with N. So from here we can find the value of R in terms of N. So let's find. So from here 2 pi Rn is equal to L. So from here R is equal to L upon 2 pi N. Putting this value in this equation, we have B is equal to mu naught upon 2 into Ni upon R value is L over 2 pi N. So from here we get B is equal to mu naught pi I over L into N square. So from here we can see that B is directly proportional to N square. Let's highlight it here. This is the relation between B and N. And let's check the graphs again to check the relation of B with N. So in graph 1 does not shows B is directly proportional to N square, but graph C shows B is directly proportional to N square. Hence graph C is also correct. Hence the correct option to this solution are B and C. I hope you understood it well. Thank you.